Hello students, greetings of the day. This is your NE Rao, faculty in Physics Scrum, Director VIP classes. Today we talk about units and measurements. Fine? Yeah.
Like small points about measurements and units. What's that? Measurements and units. Can you define what is a measurement? If I ask you, can you measure the length of the table? What you will do? Yes? How do you measure the length of the table if I ask you to measure? Yes? Everyone should respond in the class.
Centimeters.
Yeah, I will measure in terms of centimeter. How we will measure? Okay, of course. We're telling the reading in terms of centimeters or meters.
Scale.
Find it. Or a tape, and what we will do? So we'll just go on measuring. For example, if I ask to measure the length of this particular whiteboard, what do we do? So this is a scale, for example. Okay, this is a known quantity. We know. So then the scale is 30 centimeters. Now, if I want to measure, what I will do? I will take the standard one. So starting from actually this side, cannot this side. I'm taking from here, here to and here. Yeah. How much this particular length of this particular whiteboard from here to there? If I ask you, what do you do? You will take a standard scale or a tape and you just go on saying this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 is there. Therefore, I can say, sir, the length of this particular whiteboard is 10 times standard unit which you are using. Standard scale you are using, isn't it? So, what is the value of this particular scale? Generally, we have 10 centimeter or 15 centimeter or 30 centimeter, isn't it? Isn't it 30 centimeters? 15 centimeters. A small scale is 50, and big scale is how much? 30. Say, for example, this is 15 centimeters. So, I can say now this is 10 into the writing what here? 15 centimeter. How much, right? 150 centimeter. And as you know very well, 1 meter, how many centimeters? 100 centimeter. So 1 centimeter is how much now? 10 power minus 2 meters. Up to here, 150 into 10 power minus 2 meters. That is 15 into 10 power minus 1 meter. And now 10 into 10 power minus 2, 10 power minus 1 will come. How much you get? 1.5 meters. The length of this particular whiteboard you are saying is 1.5 meters. Okay, actually what we have done when I asked you to measure, so we are comparing. So this is unknown quantity. We don't know how much its length is. We are comparing this unknown quantity with what? Known standard quantity. So this we know the length of the scale. We have fixed it. The standard quantity. So this process of comparison of this unknown quantity with a known standard quantity is called measurement. So what's a measurement? What is measurement now? Or a definition? The process of measurement. Let down everyone. The process of comparison of an unknown quantity. Process of comparison of an unknown quantity. This is not known to us. Unknown quantity. What's that? With known standard quantity. With known standard quantity. The process of comparison of an unknown quantity with a known standard quantity is called what? Measurement. And what this standard quantity is called? This is standard quantity means the scale which I have taken. This standard quantity with respect to which you are measuring this unknown quantity. The standard quantity is called units. The standard quantity is called what? Units. So of course, say whatever you got here, meter, no, meter, or you can say centimeter. What are these? They are the standard quantities. Okay, we are defining 1 centimeter length means how much? The gap between 2 marks on this scale, say this much, is 1 centimeter. 1 meter means how much? This much length is taken as 1 meter. So standardly we are defining them. They are called standard quantities, and we call the standard quantity as units. What we call the standard quantity as? Everyone? Standard quantity unit is standard quantity with respect to which we measure unknown quantity. Okay, so before entering the chapter, we should know certain basics. Those basics I am discussing, the part of syllabus. So the standard quantity with respect to which we measure what? Unknown quantity is known as their units. Now standardly, all of you know very well how many system of units we have. In your 8th class, 9th class you studied. How many system of units we have? Yes, please everyone. I want answers from all of you. I should not take your names. You tell. How many system of units we have? How many you know in your 9th class, 8th class, 10th class?
Sir, 7.
No, 7. The quantities we define 7. I will come to that point. I'm asking system of units. Standardly, how many system of units we define?
3, sir.
Very good. System of are they? System for measuring the physical quantities. I will define what are physical quantities also. And what? FPS. Nowadays, more general we are using SI system. This is Steam International D-Nice. Nowadays, we are talking about this SI system. And first of all, now actually, what quantity of this particular board we have measured? Certain portion of what? It's what you have measured? What quantity? Which physical quantity you have measured here? Today, I want interaction, man. If you don't interact, I don't feel like good. So please talk something, whether right or wrong, doesn't matter. Following?
Unknown quantity, sir.
What is that unknown quantity? What is that unknown quantity you are measuring here? From here to here, you are measured now. What is this? Length of the board you have measured. What you have measured? Length of portion or length of border. So this length is a physical quantity. Because we can able to measure it now. So this kind of quantities which can be measured are called what? Physical quantities. The quantities, take the heading, all of it on. Physical quantities next. So the measurement is a process of comparison of unknown quantity with a known standard quantity. The standard quantity we are calling as unit. So of course we defined a system of units. Again I will come back to that. CBSE, MKS, FIS system. But what we have measured? We have measured one physical quantity. What is the physical quantity? That is length. So how do we define physical quantities? The quantities which can be measured are called physical quantities. Okay. So for example, so you are feeling very happy. Can you measure the happiness? Yes, sir. I feel this much happiness. Yes, sir.
No, sir.
We cannot measure them. You can feel them. Yes or no?
Sir. Yes, sir.
The quantities which can be measured, are called what? Physical quantities. Now, another definition here. The quantities which can be measured which can be measured are called physical quantities. Okay, so I will ask definitions tomorrow, everyone. Now, syllabus I told already. Take this one. So, first one, what should I take? Measurement means what? An example you have taken for definition of units. Okay, you can take up system of units. Okay, then more general we are this SI system. I will come back when I told already. Take this one. Then go for heading of physical quantity. What is physical quantities? The quantities which can be measured are called physical quantities. If I ask you what is your height, what do you do? If I ask you what is your height, what do you do?
We measure and
the
say
length.
I will measure by means of a tape or a scale, but generally height is expressed in terms of feet and all, no? Isn't it? So 1 feet is some 30 point something, 5 4 centimeters something, no? Isn't it? So conversions are there. So fine. So we are measuring. You are by unknown quantity. Okay, unknown quantity. The height is measured by known quantity. So height fine. If I ask you what's your weight, how you will report your weight? Can you tell me? So I love this portion. How do you report your weight?
In kilograms.
Yeah, in terms of kilogram you mentioned, no? Yeah. What is the weight? If I ask you weight of a person, for example, from 60 or 90 kilogram. 90 kilogram or kilogram weight is important. Which is correct? Kilogram is correct or kilogram weight is correct. Which is correct?
Kilogram.
No. But difference between these two. Everyone. kg and kilogram weight or kilogram force in your 9th class you studied. Kilogram force or kilogram weight. Kilogram. What this gives? Participate in the discussion, man. I should take your names again. I have to come to the camera and I have to check your names. Don't make me to work like that. Interact voluntarily. What difference between these two? Angelina, what difference between these two units? What this refers and what this refers?
Sir, kilogram is measure of mass and kilogram weight is measure of the weight.
Measure of mass. And one more is?
It is the measure of the weight, kilogram weight.
Yeah, mass and weight are different things here. Don't say your weight is 100 kg, 90 kg, 60 kg. Wrong answer. Okay, so kilogram weight refers the what? Actually, what is weight? Can you define what is weight? What is mass and weight? Let us define these two quantities. Every day you get these words. Mass and weight. Can you define these two quantities? Define these two quantities. What is the mass? What is mass? If I have a chalk piece, you might have seen. Okay, chalk piece. Say, Arjun, this is chalk piece. So I can make it into small pieces, no? Fine particles I can know. The fine particle what is called matter. So how much amount of matter is present? The quantity of matter present is called what? Mass. Yes or no?
yes, sir.
Yes, sir.
In Newton
Yes,
scientific, when you throw the apple upward, it is coming down. Or if it detach from the apple tree, it is coming down. So why it is coming down? Why the apple is falling down?
Gravity.
Yes? Yeah?
Gravity.
Because of gravitational force.
Gravitational force.
Because of gravitational force. That gravitational force with which an object is being pulled towards center of the earth is called weight of the object. Remember what is weight? So mass is the quantity of matter. How much matter is present in a body? So quantity of matter present in a body is defined as mass. What is weight? Weight is defined as force with which the body is attracted towards center of the earth. Towards what, sir? So force with which the body is attracted towards center of the earth is defined as weight of the body. So weight is a force, mass is a quantity of matter. Quantity of matter. Keep in mind all of you. Again, I will ask these questions to you. Note it down. Mass and weight difference. And see, keep in mind, mass throughout the universe remains the same. But weight from planet to planet changes. Location to location, the weight changes. How it changes? www.gravitation.com. In that chapter, we'll study. Don't worry. Okay. So now coming for here, the force with which the body is attracted towards center of the earth is called weight. The mass quantity of matter. Weight was saying is a force. might have heard the terms vectors and scalar. Have you heard the terms vectors and scalars?
Yes, sir.
Yeah. So we'll talk about those things also. Okay. So your force is a vector quantity. Mass is a scalar quantity. Okay. Mass throughout the universe remains same. Weight is not same. It changes from point to point, planet to planet, location to location. Weight changes. Ready? So these are the difference between mass and weight. How do we measure mass? Mass is measured by means of what? Balance, of course, in terms of kilograms and all. It is in terms of kilogram weight. You know, in the 9th class, you might have studied formula. F is equal to ma. And when you throw the ball, we will discuss in detail. You do not to worry. In law of motion will come. I will discuss. Don't be panic. When you leave this body, generally you know terms. That's why I'm just making you to habituate the terms. Velocity is 0. When you leave it, what's happening? Velocity is increasing. There is change in velocity. Change in velocity is called what? Acceleration. Okay. So Newton measured the value of mathematical formula. I will be deriving this formula there. Just as you know the formula in 9th class, I am recalling it. So F is equal to m into a. So here, when I am releasing this body, acceleration is produced in this body with a gravitational pull of the earth. So this acceleration is called acceleration due to gravity g, and its value is 9.8 meter per second square near the surface of the earth. Near the surface of the earth. And this m into g is called weight. M into g is called what? Weight of the body. Of course, more is the mass, more is the weight. Okay, lesser is the mass, lesser is the weight. So, a lesser mass body is attracted with less force. A larger, heavier mass is attracted with larger amount of force. Weights, of course, definitely different. It is m into g. Okay, so this is what weight and this is what mass. And what are physical quantities? The quantities which can be measured are called what? Physical quantities. Can I have this part? All of you.
Yes, sir.
Now coming for this discussion, we had mass and weight. Now this mass is one physical quantity you could be able to measure. The quantities which can be measured are called physical quantities. Can you name few more physical quantities which you can measure? Everyone should answer. Can you name few more physical quantities which you can measure? Yes?
Length, breadth, height.
Yeah, fine. Length, breadth, height, all they come under length only. Of course, in one direction, if you consider a textbook or kind of thing, bottle or anything else, length and breadth, they are both, they could come under the heading length only. Okay? All are together only.
Volume.
Next, physical quantity. Just now you have seen mass. You can measure mass. Mass is a physical quantity. You can measure weight.
Weight.
Quantity. What is
Volume.
beautiful answer. Volume. So volume you can measure. Volume is a physical quantity. Next. What
Area.
beautiful answer. You can measure area. Area is physical quantity. Next.
Time.
Beautiful. You can measure time. Time is a physical quantity. Next.
Temperature.
Speed.
Yeah. You can measure temperature. In summer, hot
Speed.
temperature 27 or 37 degrees Celsius. No, you can measure. Now, what else? Everyone.
Intensity of light.
Speed.
Okay,
Speed.
light, fine, speed, intensity of light. Okay, I mentioned intensity of light. Now, next. What else you can
Refractive
measure?
index.
Huh?
Refractive index.
Yeah, in first class we discussed refractive index. This is a measure of bending nature of light, mu. We can measure it. Now next, density. This is called optical density. It is called mass density. Keep in mind, both are different. Refractive index is also called optical density. This is called mass density. How you are define density as? Density is mass by volume. Isn't it? Clear, everyone? Yeah, like this we have different quantities which we can measure. So all those quantities which can be measured are called physical quantities. Then what? Examples of physical quantities. A definition and then the examples. Now, after this, so basically in standard way, as I was saying, system of units. So we are taking three quantities here. All are length, mass, and time. In CBSE system, length is measured in terms of centimeter, mass in terms of grams, time in terms of seconds. In MKS system, standard system we are defining it. Length is measured in terms of meter, mass in terms of, yes, the answer there.
kg,
Kilogram, and time is in seconds.
seconds,
FPS, F stands for food, P for pound, per second. Okay, British units. So food is length, pound is what? Unit of mass, and second is unit of time. Standardly, we define three system and corresponding units in CCS, MKS, FES system. Now, nowadays, all scientific community has accepted a standard system that we are calling as SI system, that is System International Units. This is the extension of MKS. Okay, in this system, we are standardly defining 7 quantities as base quantities. Okay, how many are? When you find them. In SI system, the scientific community, okay, scientific community throughout the world, okay, in SI system, so how many quantities are taken? 7 quantities are taken. 7 quantities are taken as base quantities. Okay, and they are defined as fundamental physical quantities. They are defined as what, sir? They are defined as fundamental physical quantities. So, in a case of physics, we have 7 fundamental physical quantities. Okay. So here, fundamental physical quantities. Fundamental physical quantities. Okay, what are they? Or you name some of them. Length is a fundamental. It's defined standardly by scientific community. Mass, fundamental. Okay, so I just I will be rounding up them. Length, mass, here time is fundamental. Temperature is fundamental. Luminous intensity is fundamental. Okay, and 2 more are there. Here we define them as amount of substance. Okay, amount of substance, electric current. All these you can take examples of fundamental quantities. But in SI system, how many you are defining as fundamental? How many? How many you are defining as fundamental in SI system?
7 quantities, sir.
7 quantities are taken as base quantities. So fundamental quantities. What are fundamental quantities? First of all, we define them. So fundamental physical quantities. See, scientific community has decided. See, actually, if I ask you length of 1 meter, some person may say, sir, this much length I will take as 1 meter. One more person, sir, I will take this much length as 1 meter. Some person says, I will take this much length as 1 meter, which is correct. There should be some standard. In Hyderabad, 1 meter, okay, length of wire, okay, how much? In Vijayawada, okay, in Vizag, in Mumbai, Delhi, everywhere 1 meter must be same only. It should not vary. Getting? So, or in America, or in Britain, any other country also, 1 meter means that should be fixed then. That's how all scientific community has gathered together and they have defined 7 base quantities. One length is defined as fundamental. Mass defined as fundamental. Time is defined as fundamental. So the quantities which do not depend on other quantities for their measurements, they are taken as fundamental quantities. The quantities, what sir? The quantities which do not depend on what? The quantities which do not depend on other quantities for their measurement. The quantities which do not depend. These quantities do not depend on other quantities. Further, what sir? The quantities which do not depend on other quantities for their measurement. They are called fundamental quantities. So in SI system, the scientific community system international units has decided to take 7 quantities as base quantities. Already I have marked here. I wrote 2 more also. Amount of substance, electric current. Everyone should know these quantities. Now they are what are they? Their measurement. They are called fundamental physical quantities. How many are there? 7 fundamental physical quantities. They are taken. These 7 quantities are taken as base units. Base quantities. 7 quantities. 7 quantities are taken as base quantities. Okay. What first one is? First one is length. And second one is mass. Length, mass. And third one is time. Okay. Fourth one is order is not important. You can take anyway. Length, mass, time. Next is temperature. Capital T. Symbol it is. So length, mass, time, temperature. As your friend said here, luminous intensity. Again, this measurement error chapter, last chapter will take it. How much is required, that much only we are taking from the chapter. Right chapter in sum of all chapters. Will be taught errors and all. Later I will be teaching. Just I will be taking what are units, what are fundamental, what are derived, what are the system of units, what is dimension formula. This much only discussion. In error, types of errors, how to minimize the errors, percentage errors. Okay, just how much required now for understanding next chapters, that much only I am taking here. Now, so length, mass, time, temperature, luminous intensity, symbol is I. And next, what it is? Next one is what? Amount of substance. And next one is electric current. Okay, I. So these 7 quantities are taken as base quantities. Okay. So now this one, everyone. I have taken these examples of physical quantities. Everyone, running notes is mandatory. Everyone has to give one physics, one chemistry, one mathematics notebook, and everyone has to write running notes. So you have to show your videos, what you are writing. Also, you should know actually. So, following. Hello, everyone. Yeah.
Yes, sir.
Now, so coming first, I have this example for fundamental physical quantities. I'm rubbing this part, okay?
Sir, can you repeat the fundamental quantities?
Yeah, the quantities, yes, the quantities do not depend on other quantities for their measurement. They are taken as what? Fundamental quantities. And how many we have defined like that? We have defined 7 quantities like that. So this is length, mass, time, temperature, luminous intensity, amount of substance, electric current. These 7 quantities are basically defined as fundamental.
Can you repeat fifth quantity again?
Someone was saying something. Yeah, can you repeat? Okay, please can you repeat? What's your doubt? Yeah, 7 quantities are fundamental. So length, mass, time, temperature. Now see what is length actually? The extension between 2 points can be defined as what? Length. What is mass? Quantity of matter is defined as what? Mass. What is time? How do you define time? How do you measure time, or how do you define time first of all? Yes, before entering the class and after leaving the class. From interval, some space, what do you can say? The interval we have left, no. The gap between 2 events. Entering the class is one event, leaving the class another event. So whatever the gap between 2 events is defined as time. The gap between what, sir? 2 events is defined as time. That is taken as fundamental. What is temperature? What is temperature? In 8th class, 9th class you studied. How do you define temperature? In the first class also we have discussed. We'll discuss on the chapter names. In a local language, what do you say? Degree of hardness or coldness of a body is called temperature. What is temperature? Yeah, all these things you should know, man. What is temperature? Discuss in thermodynamics. Temperature actually is nothing but average kinetic energy of molecules we define. In work energy power chapter you study 9th class. Okay. So when you are doing work on an object, there is a change in velocity of the object. And the body gains some energy. The energy by virtue of its motion is called kinetic energy. If you take any particular substance at normal temperature, all the molecules in vibrational states, they'll be moving. So, what is the total kinetic energy, average kinetic energy? That is defined as temperature. We discussed in detail in thermodynamics. When you are immersing your fingers in the hot water bath, suddenly you will get a heat shock, no? Why so? For the reason, when you are immersing your finger in the hot water bath of 100 degrees Celsius, all the molecules are in vibrational states. When you immerse, the large amount of energy flows from that particular vibration energy of the molecules will flow to your body and you will get a heat shock. How do you get current shock? When you put your finger in the socket, what happens? A large amount of energy is flowing through your body to the ground. So getting heat, that is called current shock. It's a heat shock, that is current shock. Okay, so the degree of hardness or coldness in your 9th class, 8th class definition. The intermediate definition is average kinetic energy of molecules is defined as temperature. How we have defined temperature? Note it down. Note it down. Average kinetic energy of molecules of a body is defined as temperature. Is it okay, everyone? Just note down for time being. I can be explaining in detail in thermodynamics chapter. Average kinetic energy of molecules of a body is defined as temperature. Fine. What is intensity means what? Like for example, light is falling on a surface. Okay. So light falling on a surface. Light rays are falling here. So energy is being received by the surface. So how much amount of energy is received per unit time, per unit area is defined as intensity. Like when you searchlight, for example, I am putting a searchlight here like this. The dark patch is formed, white patch is formed. So energy is falling. So on a particular area, if I take any particular area, if I divide this area into unit areas, so how much amount of energy is falling per unit area, per unit time is defined as intensity. Amount of energy falling per unit area per unit time is defined as intensity. Okay, everyone. So, like for example, in the hot summer day at 12 o'clock noon, sun rays are falling completely vertical. If you take particular area, the maximum energy falls during that all vertical rays are falling. Maximum energy is received. So, how much amount of energy received per unit area per unit time is defined as intensity. Clear, everyone? Hello? Audible, everyone?
Yes, sir.
Respond. What about amount of substance? For understanding about amount of substance, I will give an example for all of you. Like we say H2 plus O2 gives rise to H2O. Can you balance this equation? When you want to form water, you will mix hydrogen and oxygen in proper proportions. That is called law of definite proportions. In chemistry, we will be studying this one. When I add hydrogen and oxygen in proper proportions, I will be getting what? Water. Balance this equation. Here 2 hydrogen atoms, here 2, here 2 oxygen atoms, here only 1.
2H2O.
2H2O,
2O
sir.
plus O2 gives rise to
2H2O. But hydrogen becomes now here 4. So make it here 2. So 2H2 plus O2 gives rise to 2H2O. What is the physical meaning of this equation in chemistry? The physical meaning is 2 moles of hydrogen reacts with 1 mole of oxygen gives rise to 2 moles of water. Apart from this, if any other proportions if you take, you won't get water. You may get hydrogen peroxide H2O2. Therefore, always when substances, when atoms or molecules, when they combine to give particular compound or substance, they always mix in a proper proportion. This law is called law of definite proportion. This law is called what, sir? Law of Definite proportion. Keep in mind in chemistry we'll study. Again in thermodynamics, kinetic theory of gases again we'll study this. Moles of hydrogen reacts with 1 mole of oxygen gives rise to 2 moles of water. So this particular mole is there now. It is defined as amount of substance, how much you are taking. It is defined under the heading of what quantities? Fundamental quantities. So just like this 7. One more is the electric current. So electric current in 10th class you studied electric current. What is your study? Tell me. How you define electric current? 2 mole of hydrogen plus 1 mole of oxygen gives rise to 2 moles of water. And the physical meaning of this one. How much quantity? That is the amount of substance. It is measured in moles. Now coming for electric current. How you are define electric current? Can you tell me? How you are define electric current? So I have this portion, right? So I have this part of board.
Yes, sir. Yes, sir.
Now how you are define electric current? Can you tell me?
In amperes, sir.
Ohm's law, electric current, power, series combination of resistors, parallel combination of resistors, verification of Ohm's law, blah blah blah. All things you studied. No, what is current? Yes. How do you
So
define
the
electric
flow
current?
of electrons.
Yeah. How do you define current?
Electrons.
Cross section of a conductor. We have large number of valence electrons. 3 electrons are there. When you apply some potential difference across the ends of the conductor, what happens? So all metals are having large number of this kind of 3 electrons. Okay. So when you apply potential interference of battery positive negative, this is a higher potential, this is a lower potential. Electrons are having negative charge. This is positive. So electrons experiencing force. So each and every electron start experiencing force. Okay. At a particular cross section, if n number of electrons are crossing, the total negative charge crossing to left, how much? Number of electrons into charge of electron. This is the total negative charge crossing the cross section. Which is equivalent to equal positive charge crossing rightward. This you know very well. So if you are standing across this cross section and you are counting how many number of electrons are crossing. So the Q is the total charge crossing in t seconds. In unit time, how much amount of charge crosses? That is Q by T. Whenever we divide one physical quantity with time, that is called rate of change. What term we use? Rate of change. So rate of change of rate of flow of, you can say, charges are flowing. Rate of flow of charge is defined electric current. It is taken as fundamental physical quantity. Okay. Again in detail we study in secondary electricity. Don't worry. So here what? Rate of flow of charge is defined electric current, which we are taking under the heading of the 7 fundamental physical quantities. Okay. Not on fast. And units will write there. Units also will write. The SI system. Now, what is unit in SI system? Can you tell me? 7 quantities, no? And SI unit you can write down here. Here you can write down. What unit of length in SI system? Meter. Keep in mind. SI is extension of MKs. Meter, kilogram, second. Just extension. Now, mass. In SI system, mass in terms of kilograms, kg. Time in terms of what? Seconds.
Seconds.
Temperature in terms of what? Kelvin. Kelvin symbol is capital K. Luminous intensity measured in terms of candela. What are it is? Luminous intensity is CD. CD means candela. Amount of substance. Just now I told 2 moles of hydrogen, 1 mole of oxygen. No. So amount of substance is measured in terms of what? It is measured in terms of moles. Symbol is MOL. MOLE. Symbol is MOL. Okay, these are the 7 units. 1, 2, 3, 4, 5, 6. And electric current. How you are measuring electric current? In terms of yes, answering. No interaction, man.
Electrons.
Of course, man. How you are
Ampere.
Volts.
in terms of unit of current is what?
Volts.
Ampere. Ampere.
10th class ho gaya. Huh? Completely forgetting. What is that one? Ampere. Symbol is A. Okay, the 7 base quantities we are discussing reading. Note it down fast. The quantities which do not depend on other quantities for their measurement are called fundamental physical quantities. 7 quantities are defined and corresponding SI system. And I also mentioned the meaning: what is mass, what is time, what is temperature, what is intensity, what is the amount of substance, what is current. We understand what are they. Okay. Now we go for other quantities. These are standardly defined now. So before that, I will define 3 quantities standardly first. This is length, mass, and time. So actually, how we are taking very important, right? This one. So just now before we discuss, 1 meter wire in Hyderabad means this much. In Mumbai, this much. No, it has to be same, isn't it? So how they have defined? So actually, in the International Bureau of Weights and Measures, we have a kind of a laboratory kind of thing or museum kind of thing. Okay, in International Bureau of Weights and Measures, International Bureau of a kind of museum, a scientific community museum is there, a kind of laboratory is there. In that lab, we have a metal rod, actually the alloy. This metal rod made up of platinum and iridium. Platinum and iridium. The mixture of these two rays. Platinum and iridium. This is the alloy. It's a metal rod made up of platinum and iridium. Okay, there are 2 marks on this one. This is first mark, second mark. So on this one, the gap between these 2 marks is taken as 1 meter standard. So in the International Bureau of Weights and Measures, a museum or a kind of laboratory, scientific communities laboratory, in that we have a rod. Okay, made up of which metal? Alloy. Mixture of metals is called alloy. Platinum and iridium. And on that we have 2 marks, fixed marks. The gap between these 2 marks is taken as 1 meter. Anything which is 2 times is called 2 meters. 100 times is called 100 meters. 1000 times is called 1000 meters. That we call as 1 kilometer. That is the standard quantity. And that standard quantity with respect to which we measure other quantities, they are called what? Units. So unit of length is taken in SI system as meter. 1 meter is how much? This much length is taken as 1 meter. Similarly, what about mass? So same in this International Bureau of Weights and Measures, near Paris it is, in London, near Paris. Okay, so one we have a lump of mass. What we have? Lump of mass. Okay, lump of mass, which is made of again same metal, platinum and iridium. Platinum and iridium made up of. Why you are taking that material, you may get the doubts. Why we are preferring that material only means its dimensions should not change and should not get corroded. That's why we have preferred alloy. Okay, and with the temperature and pressure variation, there is no change in dimension generally. When you increase the pressure, when you increase the temperature, generally objects change dimensions. And we have seen yesterday expansion. Length may expand like railway tracks. We have seen the gap is left. Okay, for pre-expansion, the gap is left. So this is approximately expansion is negligible. Okay, that's why we prefer the material known as platinum and iridium. That is the reason. So a lump of mass made up of platinum and iridium kept in the International Bureau of Weights and Measures, its mass standardly taken as 1 kg. Its mass standardly taken as 1 kg. Anything 10 times this mass is called 10 kg. 100 times is called 100 kg. That is called 1 quintal. Yes or no? Getting?
Yes,
So,
sir.
quintals, tons, 1 metric ton, and all everywhere. So like that is standardly taken as 1 kg mass. Now we define time units in seconds. So like we are defining 1 meter means how much, 1 kg how much, and 1 second will be how much. How do we define 1 second? Yes, Kiran Mandal. Yeah, this is about first one about this spoke about length means 1 meter is how much? 1 kg means how much? 1 second means how much? See, actually, you might be knowing in olden days, our grandfathers and great grandfathers. So sometime when the sun comes now, based on the shadow of the sun, they used to tell the time. Yeah, this is middle of the day, starting early. It is about the evening. So they used to see in the shadows at home. Actually, I remember my grandfather's. Okay, they used to tell when the shadow comes this much. Yeah, it is 1 o'clock. When the shadow is over here, 2 o'clock. Like that, they used to mention. So they have taken the mean solar day. One mean solar day, how much day? How many hours you have taken as one mean solar day?
24
Yes.
hours.
How many hours? 24 hours taken as mean solar day. Okay. Now early morning to next again early morning. How much right? Morning to okay, for example, morning again 7 o'clock to night 7 o'clock, 12 hours. Again 7 to again morning 7. 24 hours is counted as what? One mean solar day, average day. So here again we have known every. How much we have taken? 60 minutes. So 24 into 60 into 1 minute, how many seconds? 1 minute, how many seconds? 60 seconds. So this will be multiplying. How much you will be getting? 86,400. So this is taken as one mean solar day. And if I want 1 second to transfer this side, 1 by 86,400 parts of one mean solar day. One mean solar day is taken as 1 second. In olden days, before we have defined like this. Now in modern definition, it is measured in terms of vibrations of cesium atom. Okay, we learn that one. So when cesium atom vibrations are there, so what is how many number of vibrations a cesium atom is performing? Okay, in a particular duration of time. That is means they counted the vibrations. Okay, to number to complete that many number of vibrations, how much time cesium atom takes? That is defined as 1 second. Okay, now modern definition. Now previously we have defined like this. So 1 by how much? 1 by 86,400th part of one mean solar day is taken as 1 second. 1 by 86,400th part of mean solar day is taken as 1 second. This is how standardly we define three quantities: length, mass, time. And remaining things, upcoming chapters will come. So to that, understand how much 1 ampere current means, how much you know very well. How much 1 ampere? 1 coulomb by 1 second. If 1 coulomb of charge flows through a cross section in a duration of 1 second, that 1 coulomb per second we define as 1 ampere. 1 ampere. That is 1 ampere. That is current. 1 ampere. Other we define other quantities also we define. This is what definition of how you are taken length and how you are taken mass and how you are taken time. These are the fundamental main physical quantities. Okay, make it fast this one. Everyone. Everyone following?
Yes, sir.
Yeah, share up this one now. Current also 1 coulomb per 1 second is called 1 ampere. And other quantities which depend on these quantities set. Other quantities which depend on these quantities. Okay. They are called derived quantities. So the next heading you can write down as derived physical quantities. Can you see here? Board is visible? Yeah, derived physical quantities. Yeah, the quantities which depend on fundamental physical quantities. The quantities which depend on fundamental physical quantities are known as derived physical quantities. Can you give some examples for this everyone, please? Can you give some example for derived physical quantities? 7 quantities.
Volume,
Yeah.
sir. Volume,
Yes?
acceleration,
Oh, very good. Volume.
speed,
Yeah. Acceleration.
Velocity.
Velocity.
Fine. Velocity. And next? Yeah. We'll take the first three. These three will take first. What is volume actually? If I ask volume of a cuboid pipe. If I ask volume of a cuboid, length into breadth into height. Isn't it? Length, fundamental, breadth also a kind of length, fundamental, height also kind of length, fundamental. So this volume depending on fundamental physical quantity. And hence it is what? It is what quantity?
Derived physical quantity.
Yeah, take next example, we have taken acceleration. What is acceleration? You know, I will define again in kinematics, don't worry. Just what is the knowledge you have, just tell me. What is acceleration? How you have defined change in velocity by time? Or start, if the initial velocity is 0, v minus 0 by t. You can say v by t. What is velocity? Displacement by time. I will discuss again what is velocity displacement. For time being, your previous knowledge I am talking here. So velocity by time, velocity means displacement by time by time. What you will write there? Displacement by time square. Now look at this expression. Displacement, a kind of length. Length is a fundamental, which you all discussed previously. Time is fundamental. So this physical quantity acceleration, depending on fundamental physical quantities. And hence it is a derived physical quantity. And one more we have seen velocity over anyhow. So third we have taken velocity by displacement by time. Displacement is length, time is fundamental, length also fundamental. So velocities. You can take density. What is density? So I will again take up this tomorrow. So mass is fundamental. Volume is length, breadth, height. For a solid if you take. Okay. So our length, breadth are fundamental. This is fundamental. So density is what kind of physical quantity? Density is a derived physical quantity. Is it okay, friends, everyone? So today's discussion is mainly about what is the measurement, the process of comparison of unknown quantity with known standard quantity is called measurement. Standard quantity is called unit. You have defined 3 system of units you have defined, and later, so the community or scientific community has defined one system called SI system. In SI system, standardly we define how much 1 meter means, how much 1 kg means, how much 1 second means. Apart from these 3, again 4 quantities we have taken. Okay, so total 7 quantities are taken as base quantities. Okay, 2 more are there. Tomorrow I will discuss them. Time is not there. So and next we have taken about derived physical quantities. Is depend on fundamental. They are called derived physical quantities and examples. Okay, this is today's discussion. Tomorrow I will talk about again a little more about density and all, and then I will take 2 more supplementary quantities we have in this derived fundamental physical quantities. I will talk about them, and then we go for dimensions. Okay, everyone, note it down, and we'll close the session. Thank you all.
sir. I have a doubt.
Yes, please.
Sir, is charge a derivative quantity?
Which one?
Charge.
Yeah, charge. Current is fundamental, no. I is equal to Q by T. So Q is equal I into T. I is fundamental. Time also fundamental. So charge is derived quantity. You are right.
Thank you, sir.
Okay. Fine, everyone.
Yes, sir.
Yeah. So shall we close the session then?
Sir, can you explain length and mass ka?
Length and mass ka definition. Nothing is there. One rod is there in the two marks are there in the rod. The gap between the rod, the 2 marks is taken as 1 meter. Mass is we have some lump of mass made up of that metal, platinum, iridium. Its whole mass is taken as 1 kg. Anything 10 times is called 10 kg. Okay, clear?
Yes, sir. Thank you.
Yeah, fine.
Sir, what about angle?
That tomorrow I said no. Two more quantities are there: angle, salt angle, supplementary. Tomorrow we'll discuss. Okay.
Okay, sir.
You're fine. Then thank you. Shall I close the session?
Yes, sir.
And I request everyone.
Yes,
I request
sir.
everyone to respond for the classes. Then only we'll understand. Okay.